Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy is going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello, everybody, and welcome to Wednesday Night Math Night. Like Dr. A said, I am Amy Sink, and I'm one of the math specialists here at the Learning Liaisons. And we just love what we get to do, which is hang out here with you every Wednesday night and just go through a few math problems. We will go through about 10. Sometimes we get through 10. Sometimes we don't get through 10. But we will go through about 10 problems. And this is really for you. So you'll notice that sometimes we will post on our Facebook page asking, what do you want us to go over? I always have a next week section listed. And so I have a next week section that if you have any questions or there's things that you want me to go over, I add it to this list. So this is crafted to help you. The goal is to help you feel more confident and competent in your math skills. And so we are here to serve you. So with that said, I am just lucky that I get to do this with you. So a little bit about me. I am from Central Florida. I am certified K-12 math. Math is clearly my jam. But I love math. I love when I get to help people with math. I love when I get to build that confidence in students and teachers. And so math is my thing. We have a Great Dane who's like 160 pounds, and he thinks he's a lap dog. And we do not go to Disney every weekend. I love Disney, but it is just too hot for all of that right now. So yes, I am from Central Florida. No, we don't go to Disney every weekend. You will see some problems that have some asterisks. Anything with an asterisk is something that was specifically requested by somebody, whether it's the content or the actual a similar problem. So anything with an asterisk, you'll notice, is something that was specifically requested. And I always like to do a get to know you question. So in the comment box, let me know where you're from, what test are you prepping for, And do you have any pets at home? We only have the Great Dane, and that is our only pet. Do you have pets? Are you a dog person? Are you a cat person? Are you a bird family? Are you an iguana family? Do you have all of the above and you have a lot of animals at your house? So it just makes it feel a little less like we are sitting here in front of a computer screen, and it makes it a little bit more personal. So where are you from? What test are you prepping for? And do you have any animals at your house? All right, without further ado, let's dive right into our first problem. A rectangle has a width that is 10 less than half its length. The perimeter of the rectangle is 202 feet. What is the length of the rectangle? A rectangle has a width that is 10 less than half the length, and the perimeter of said rectangle is 202 feet. What is the length of the rectangle? So I've gone ahead and highlighted some of the critical information that they've provided to us. So we know that the width is, W is 10 less than half the length. This problem is really combining a lot of different stuff. In fact, I could probably put a little asterisk here because it's combining number and operations and our ability to translate words into algebraic functions. All of that is being done in the first part of this problem, but then it's also dealing with geometry. So we have a width that is 10 less than what? 10 less than half the length. So I want you to consider this. It would be tempting, and a lot of us are going to make a similar mistake, to do 10 minus half the length. However, 10 less than something is actually something minus 10. If you're not sure, then you can always reframe the problem. So the width is 10 less than 15. What is 10 less than 15? 5. Because 15 minus 10 is 5. Something minus 10. So if we reframe the part that is unfamiliar to us into a familiar area, then it makes it a little easier to conceptualize it. So, something minus 10. What is that something? Half the length. 1/2 the length. The perimeter is 202. What do we know about perimeter? What do we know about perimeter? Perimeter is the linear distance around a shape. Perimeter is the linear distance around a shape. So if I draw my rectangle here, the perimeter is going to be, I'm going to start here and I'm going to walk around the shape, and that is the perimeter. Area, which they didn't ask us for, but sometimes people get it confused. Area is the square measurement inside a shape, specifically a 2D shape. So the area would be that part, okay? Now, this did not ask us for that, but I'm just extending a little further to make it make sense. So I know that W, so we have a length and a width. We have a length and a width and a length and a width. So L plus W plus W has to equal my perimeter, 202, right? And I know that W is the same as, that equal sign means is the same as, W is the same as 1/2 L minus 10, which means I can replace my W's with that phrasing. And what that's going to do is it's going to allow me to operate with only one variable. So I have L plus L plus 1/2 L minus 10 plus 1/2 L minus 10 equals 202. I'm going to reconnect my iPad. All I did there was I plucked the W right out of the problem and I replaced it with something that was exactly the same. All I did was pluck that W right out of the problem and replace it with something that was exactly the same. So we have L plus 1/2 L minus 10 plus 1/2 L minus 10 equals 202. L plus L is 2L plus 1/2 L minus 10 plus 1/2 L minus 10 equals 202. A half of an L plus a half of an L is a whole L, right? A half plus a half is a whole. Plus 2, so 1 whole plus 2 is 3. So 3L negative 10 minus 10 is negative 20 equals 202. Add 20 to both sides. 3L equals 222. And now I'm going to use my calculator. Could I do this by hand? I could, but I'm just not going to right now. So divide both sides by 3 and L equals 74. Now, the problem asked us for the length. So in this case, we ended up finding the length in that first step. If we had not found the length and we had found something else, or what if the problem said, what is the width of the rectangle? We could just plug this L value back into here. So W equals 1/2 L minus 10, 1/2 of 74. I'll do that one long just to show you that it's possible. 37. 37 minus 10 equals 27. So the width is 27. They didn't ask us for the width, so we're not going to use that information, but I just wanted to show you how to solve it in case they did ask for something like that. Questions? All right, let's go ahead and move on to problem number 2, even though this says problem number 2. Problem number 3. What is the volume of the figure that would be created from the net shown to the right? What is the volume of the figure that would be created from the net shown to the right? All right, this is another geometry problem. Volume. Volume, so we talked about perimeter, we talked about area. Volume is the cubic measurement inside a 3D shape. The cubic measurement inside a 3D shape. So perimeter is the linear measurement. Area is the square measurement inside a flat shape or a 2D shape, and volume is the cubic measurement inside a 3D shape. Now, you might be looking at me going, Amy, you've lost your mind. This is not a 3D shape. You are correct. What they've given us is the net, which means they've taken the 3D shape and flattened it out. But what 3D shape would this create if we were to create the 3D shape? This would create a cylinder. How do I know this creates a cylinder? Because this is going to end up being the top, or you could say it's the bottom. This is going to end up being the bottom. And then this is going to end up being like the round side that goes around it. So we're going to fold those circles up to create that top and bottom, and that rectangle creates the part that's around it. For instance, I'm going to see if I can, here's a little teeny tiny piece of paper, but when I roll it up, you notice that it creates a cylindrical shape, right? Like there is the circle on the top and the circle on the bottom. And when I roll the rectangle up, it creates a cylinder. That's pretty cool. So with that said, how do I find the volume of really any prism-like shape? Volume equals area of the base times the height of the shape. Area of base times height of shape. Now, this only works for prismatic-like shapes. This is not a prism. A cylinder is not a prism because there are characteristics about it that don't classify it as a prism, but it really operates when we're talking about formulas like a prism because it has a base and a height. Now, if I were to draw a cylinder, there's my cylinder. The area of my base would be my circle, right? So either one or the other. And this would be the height right here. This right here is going to be the height. Well, what is this in relation to my picture right here? The 15. There's my H right here. Area of the base. So I need area formula for a circle. Area of a circle equals pi r squared. Did they give me my radius? They did not. What did they give us, though? What did they give us? The only other measurement that they gave us that we haven't used yet is 24. What is 24 in relation to my circle? My circumference. How do I know that? Well, let's get our sticky note again. When I wrap this sticky note up, it creates that circle, which the circumference, remember, is the perimeter really of a circle, right? When I unravel this, what measurement is that? When I unravel this, what measurement is that? It's the other side of that rectangle, right? So 24 is the circumference of the circle. So can I use my circumference formula backwards to figure out what my radius is? I absolutely can. Let's go ahead and do that. Circumference equals 2 pi r. So what this means is I can plug the 24 in for the C, divide both sides by 2 pi to get r by itself. So my radius is going to equal 12 divided by pi. Now I can find the area of my circle so that I can find the volume. So my volume formula is volume equals area of the base times my height is 15. Area of the base is pi r squared times 15. Are you following me? So volume equals pi times 12 divided by pi squared times 15. 12 divided by pi squared creates 12 times 12 is 144. Pi times pi is pi squared times 15. This pi can cancel with one of these pi's. So I have 144 times 15 divided by pi. $144 times 15 is 2,160 divided by pi. Now, I'm making sure I'm 99% sure that this is correct, but I'm making sure I didn't do anything wrong. Area of the base times the height, area of the base equals pi r squared. Circumference is 24 equals 2 pi r divided by 2. 12 divided by pi r squared times that. Yeah. So this problem was created and then I never changed the answers. So in this case, the answer is E, 2,160 divided by pi. Did all of that make sense? I know that that was like a super multi-step problem, but it's important that we understand the process of walking through that. Now, if you are taking an elementary or a pre-K through 3 test, you're probably thinking to yourself, this has nothing to do with me. You're not wrong. However, don't worry. I have problems for you as we continue to work through the end. So don't leave just yet. There are pre-K through 3 and elementary problems as we work through today's content. In fact, I think it's like starting at like number 6. All right, let's go to number 4. Actually, this is for everybody. So there you go. Suppose 2 coordinates, A and B, lie on the XY plane. If the coordinates of A and B are -3, 5 and 6, -7 respectively, then what is the distance from A to B and back? What is the distance from A to B and back? Round your answer to the nearest hundredth. All right. So I'm beginning to think that those answers, given the fact that this says round your answer to the nearest hundredth, makes me think this is a fill in the blank problem. Not everybody has the luxury of having fill in the blank problems. However, this problem is for everybody. Everybody needs to understand at least the coordinate plane. And so maybe not my pre-K through 3 people, but everybody else. So we can at least do that part together. Distance is not everybody. However, that coordinate plane is everybody. So let's do this together. So coordinates of A and B, -3, 5, reconnecting. All right, so I've drawn my coordinate grid. Here it is. Big drum roll. Boom, there it is. Okay, here's my coordinate grid. Now, I'm going to plot these points. When I am plotting points on a coordinate plane, here's point 1, here's point 2, -3, 5, and 6, -7. Our X is listed first, and then our Y. X comes before Y in the alphabet. X comes before Y in a coordinate plane. With that, we always evaluate our X first. So we're going to do X, then Y. When we do this, I'm going to go across my X-axis first and then up on my Y. So negative is going to be this way. Positive is going to be this way. Negative is going to be down. Positive is going to be up. All of that makes sense, right? I'll leave the negatives and positives, but I'm going to get rid of these arrows so it doesn't junk up what we're trying to do. So we have -3. 1, 2, 3. What is going on with my iPad today? It just does not want to stay connected, which is kind of rare. Like it usually does it once or twice, not 27 times like it is today. So we're going to go -3, which means we're going to go in the negative direction to the left, and then we're going to go up 5. So I'm going to go -3, 1, 1, 2, 3, up 5. 1, 2, 3, 4, 5. And I'm going to plot my point right there. Then I'm going to do the same thing with my blue. I'm going to go +6. 1, 2, 3, 4, 5, 6. -7. 1, 2, 3, 4, 5, 6, 7. Now, if you have coordinate grid paper that they provide you, that's a beautiful thing because then you can visually see this. Now I'm going to connect my 2 dots. And they want to know the distance from A to B and then back. So they want 2 distances. Well, what is the distance formula? What is the distance formula? The distance formula is the square root of x minus x squared plus y minus y squared. Does it matter which x and which y you do first? No-ish. A lot of times you'll see the formula with all these extra subscripts, and it can make the formula confusing. It doesn't matter if you do x1 or x2 first, just as long as you follow the same y. So if you do x1 first, then you need to do the y that matches that x. If you do x2 first, then you need to do the y that's partnered with that x first. So now all we need to do is use this formula to find this distance and then multiply it by 2 because we're doing it 2 times. Now, keep in mind, some of you are going to try to count this distance on a coordinate grid. Counting it is going to be incredibly inaccurate because we are not going vertically or horizontally on a coordinate grid. So we really do need to use this distance formula. So I'm going to do the square root of x minus x, 6 minus -3 squared plus -7. Because I did the 6 first, I have to do the -7 first, minus 5 squared. 6 plus 3 is 9, plus -7 minus 5 more is -12 squared. The square root 9 squared is 81. -12 times -12 is positive 144. And this is the square root of 225. The square root of 225 is, I think it's 15, but why am I second guessing myself? Yeah, 15. And 15 times 2 is 30. So the answer to this question is 30. Questions about that one? All right, let's go ahead and we're going to skip to problem 7 so that I can make sure that I get in some of this pre-K through 3, K through 6 content that was specifically requested. So the next couple problems are really lengthy in words, but we're going to dissect them together. So let's go ahead and read this together. Miss Rivera is working with her kindergarten class on understanding how numbers can be broken apart and put back together in different ways. During a small group activity, she gives the students 10 counters and says, "Today, we're going to find different ways to make the number 10. Use your counters to show me different combinations." One of her students places 6 counters on a red mat and 4 on a blue mat. Miss Rivera asks, "Can anyone find another way to make 10 using the counters?" Another student places 3 counters on the red mat and 7 on the blue mat. Which of the following best explains the mathematical concept Ms. Rivera is teaching through this activity? Addition within 10, understanding place value in 2-digit numbers, composing and decomposing numbers to build number sense, comparing numbers using greater than and less than. So this is a heavy problem with words because it's a scenario-based question. And you and I have seen these on these exams, these scenario-based questions, these questions that feel like they take up half the page. Here's what we need to do. We need to extract the important information. Important information. Working with her kindergarten class, that age does make a difference. On understanding how numbers can be broken apart and put back together in different ways. Then the activity is that they are using counters to show different combinations to make the number 10. And then one student does it one way and another student does it another way. Really? That's all this part is saying. So that's a lot of words to say. One student does it one way, another student does it another way, and that's it. What is the teacher teaching through this activity? Addition within 10, understanding place value in 2-digit numbers, composing and decomposing numbers to build number sense, or comparing numbers to using greater than or less than. We can pretty much eliminate comparing numbers using greater than or less than. That is definitely not what they're working on, right? Addition within 10, 6 plus 4 is 10. 7 plus 3 is 10. So that could be it. Understanding place value in 2-digit numbers. We are only dealing with the number 10 and we're breaking the number 10 apart into different combinations. So we're not really diving into the understanding of place value. However, are we doing addition within 10 or are we composing and decomposing numbers to build number sense? This right here gives it away. Numbers can be broken apart, decomposition, and put back together, composition. Because they are working on composing and decomposing numbers, numbers breaking apart, numbers putting back together, they are doing composing and decomposing numbers to create number sense. They're not working on the addition skill. They're not saying here's 6 and here's 4. How many does that make? They're starting with that whole number and they're decomposing it in a variety of ways. They're not looking at the addition sentences that go with it. Now, composing and decomposing numbers sets them up for the abstract concept of addition. So yes, that is important. However, in a kindergarten class where we are working with these counters and all of that, we are composing and decomposing to build that foundation for that addition. So that's why that's the correct answer. All right, let's do the next one. Another scenario-based question. A teacher is introducing a lesson on multi-digit addition. She writes the following problem on the board. 457 plus 286 equals question mark. She encourages students to use place value strategies to solve it mentally. One student breaks the numbers apart like this. 400 plus 200 equals 600. 50 plus 80 equals 130. 7 plus 6 equals 13. And then adds those parts together. 600 plus 130 plus 13. What math strategy did the student use to solve the problem? Compensation, traditional algorithm, place value decomposition, compatible numbers. All right, so this would be a typical like second grade classroom type of problem. Second grade class. And the student breaks the numbers apart. So if we take 457 and we break it apart into what some curriculum companies and some people call the expanded strategy, we have 400 plus 50 plus 7. And if we do the same thing with 286, we have 200 plus 80 plus 6. And so the student just added the place values together and then added those numbers together to solve the problem. What the student is doing is place value decomposition. They're decomposing these numbers into expanded form to make it easier to mentally solve this problem, or not so mentally, it doesn't really matter. They are not using traditional algorithm. Why? Because traditional algorithm would have been this: 457 plus 286, 7 plus 6 is 13, drop the 3, carry the 10, 8, 9, 10, 11, 12, 13, 14, carry the 100, 4, 5, 6, 7, 743. That would be the traditional algorithm. And compensation would be something like 457 is close to 460. And so then 286 would go down because I added 3 extras to 283, and then I could add those together. That's really not an efficient way of using compensation, but that is compensation. You're compensating one number with another number to make it a little bit easier to solve mentally. And compatible numbers, it's not compatible numbers either. And so we are definitely looking at place value decomposition. Questions so far? Let's keep going. Let's go to the next problem. A jar contains 4 red, 3 blue, and 5 green. A jar contains 4 red, 3 blue, and 5 green marbles. If one marble is selected at random, what is the probability that it is either red or green? What is the probability that it is either red or green? So we're kind of shifting out of this pre-K through 3, K through 6 mindset, and we're doing a little bit of probability now. So what I want you to think about is that probability is desire over total possible. Probability is desire over total possible. So in this situation, what is my desire? My desire is to have either a red or a green marble. My desire is to either have a red or a green marble. So my desire on the top of my probability is going to be 4 plus 5. And my total possible, how many marbles are in my bag in total? 4 plus 3 plus 5. So 4 plus 5 is 9. 4 plus 5 is 9 plus 3 additional is 12. So my probability of selecting red or green would be 9 out of 12. Now, probability can get a little bit more difficult, as you and I know. We could have a probability of pulling multiple marbles. We could have a probability of doing everything but. We could have a probability of pulling a marble out, putting it back in the bag, and pulling another one out. There's a lot of there's combination probability. So there's a lot of different probability that goes into it. This is the most basic probability that we have. And so I just wanted to start there. If you want to see more probability, please let me know. And if there's specific types of problems that you're encountering that you're struggling with, don't hesitate to let me know, because there are so many different probability problems that could be included. And so if there's a narrower approach that you want me to take with probability, just let me know. All right. Now that we've done some of that, I wanted to make sure we kind of hit some of that. Let's go back to this graphing problem right here. The graph to the right shows the temperature of an area over the course of time. At what time was the temperature lowest? At what time was the temperature the lowest? This is a problem for everyone as well. In fact, this is right up pre-K through 3, K through 6. This type of graph is very typical that they might see. And we often notice when we look at our student data, especially in the schools that I've been in or schools that I've worked with in looking at data, we've noticed that students really struggle K-12 with reading and interpreting graphs. And it's something that I think is just an area of struggle, whether we believe it or not. So what time? So we're looking for the time was the temperature the lowest. Well, this is temperature. So I need to look at the graph and figure out where was the temperature the absolute lowest. So I'm looking for where I hit the graph at the absolute lowest. This dot right here is just below the 30 line. That dot right there is just below this 30 line right here. All of these other dots are going up, 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 up. It drops down, but that dot is at the 30.5 line. And this dot is between the 30 and the 35. So this is the lowest temperature, and it happens at 8:30 in the morning. So A is going to be the correct answer. All right, let's look at another problem that uses the same graph to interpret it. Let's look at another problem that uses the same graph, and we're going to interpret that graph. The same graph to the right shows the temperature of an area of a course of time. What is the range in temperatures from 10:30 to 1:30? From 10:30 to 1:30. So 10:30 is right here. 1:30 is right here. And range is just the difference. We're not counting, we're not adding, we're just taking the difference. So the temperature right here is between 32 and 32.5, so we'll call it 32.25. And the temperature right here is just above the 31, so we'll call that 31.05. Subtract 0, 2, 1. 1.2. That is closest to 1 degree, not 1.6. In this kind of problem, you just have to realize that I chose 31.05. It could have been 31.25. It could have been 31.3. And so those estimation values make it a little bit more difficult to evaluate. But as long as you're not gravely off with your estimation values, which is really what they're going for here, they want you to be able to estimate values on a graph as well as understand range. So we're looking at two different skills here. We're looking at range and knowing what range is, and we're also looking at estimation. Then you have nailed this problem. All right, we are going to finish up just a tad bit early today. So I am going to go back to my first slide. What I want you to do is let me know throughout the week if there's anything that you want to see me go over in the upcoming weeks. I am happy to include it. As you saw, there were quite a few asterisk problems tonight because those were problems that people specifically requested or concepts that people specifically requested. So don't hesitate to let me know. I look forward to seeing you next week. I hope that you're having a great summer, and we look forward to seeing you soon. Bye.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you the coupon code, all capital letters, SINK35, that's SINK 35. That will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SYNC35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.